Okay, good morning everyone. New chapter, chapter 15, visualizing solid shapes, in which we have discussed yesterday also about 2D figures as well as 3D figures. So, as per the requirement, we have one dimension, two dimension, and three dimensions. As I've told you earlier, also, if you have having a person who is walking only on a straight line, like the metro you have seen, you must have seen the Delhi metro route that is using only a single line. So please activity once again around Philip. Around later on I will explain better. Okay. Now, so in the case of metro also you must have seen you are using a straight line only. That straight line is showing only one dimension because that is enough for that. The metro is going from one point to another in a straight line, so you can show it by a straight line only. But if you are having a car, if you are having a car and you want to show the path using a straight line, that won't be good because car may go in different directions on the single plane. So for that you need at least two dimensions. For car you need two dimensions. Similarly, for an aeroplane, if you want to trace the path, you need how many dimensions? Please tell. If you want to trace path of a airplane, you need three dimensions because the airplane can go in a plane as well as it can go up and down. So better you use a three dimensions for that. Three people are there in the meeting room. Now they are increasing. Avas is there. Okay, fine. Now this we have taken yesterday also. Now they are saying match the shape with the name. Very simple. Cuboid, we all know, is made up of rectangles, a 3D shape. This is the one. Then cylinder. This is known as right circular cylinder. This is your sphere. So this is going for D. Then this is your cube. This is your cone. And this one is your looking like a pyramid. Yes, beta file marks will be added, Rian. This is your pyramid. Please name the pyramid. What is the name of this pyramid? Can you name this pyramid? We all know to name pyramid and prism, we have to see the bottom. What is the bottom of this pyramid? Sir, what is fourth dimension? As of now, there is no such thing, beta. Although there are movies like seven dimension movies, but that is not correct one. Okay, and in that they are only giving you extra effects. So till now we are having three dimensions only. Time may be there soon. Okay. Now this is your triangular pyramid. Triangular pyramid because the base is a triangle. You can see in this case the base is a triangle, that is why it is known as triangular pyramid. And if you remember, I've told you the difference between pyramid and prism. Yes, yes, Bani. In pyramid we have lateral surfaces as triangles. You can see in a pyramid the lateral surfaces are triangles. Bottom can be anything. Bottom can be square, bottom can be triangle, bottom can be rectangle, whatever you want, but the lateral surfaces or the side surfaces should be a triangle only in the case of pyramids. As you have seen in the case of Egypt, there are many pyramids, all are having lateral surfaces as triangles. Beta, there are marks for everything. Don't take anything for granted. Okay, don't ask all these questions. Now, for the prism, what are the lateral surfaces? As I've told you, in the case of pyramid, lateral surfaces or the side surfaces are triangles. What are the lateral surfaces in the case of prism? Okay, mid-gen only. Fine. Please tell class, we have done the concept of prism also. Tell me what are the lateral surfaces of a prism? Very good, Kritika. It is actually a parallelogram, but you can take rectangle also because rectangle is also a parallelogram. Okay, so it is a parallelogram. Fine. Now let's see the next thing that we are having. Okay, Now the next thing that we have done yesterday also was faces, edges and vertices. So what is lateral surface? Lateral surface is like the side surfaces. Suppose this is a cube. Ryan, please see. In this cube, this is your top, this is your bottom, and these four walls are your lateral surfaces. Ryan, is this clear to you now? These four walls are your lateral surfaces and you have a top and a bottom. Okay, so let's see. You have seen that vertices are obtained when three edges are meeting at a point. You can see when three edges are meeting at a point, we are getting what do we call as vertices. Similarly, how we get a edge? When two faces meet. When two faces meet, we get a edge. Fine. Now let's see. Okay, the number of edges, this we have done already. Now, let's take an example of finding number of faces and number of edges. Okay, in this case, tell me class, they are saying in this triangular pyramid, sorry, this is your square pyramid, I think. 1, 2, 3. No, it is triangular only. Tell me how many edges are there in this case? Sir, while counting lateral surfaces, will we count top and bottom also? No, Kritika. In lateral only you will count the side surfaces. In total surfaces, you have to count top and bottom, and normally that is different. First, tell me, is this a square pyramid or a triangular pyramid? Please tell. Is this figure a square pyramid or a triangular pyramid? Okay, it is looking like a square pyramid, but I'm afraid it is different because as per them, 1, 2, 3, and 4, they are saying there are four faces. So can we have four faces in a square pyramid? Please tell. I was also thinking the same because diagram is not completely done. Because they are saying on their own there are four faces, so we have to make it a triangular pyramid because in triangular one is the bottom, second, third, and fourth. Five faces in triangular. Lavya, if you are thinking it is a square pyramid, try to think one more time. So see, if this is the base, the square, then first face is the bottom face, second, third, fourth, and fifth. Then we will have five faces, na? If you take it as, I hope you're getting my point. So there are only four faces in pyramid. Okay. So this one is triangular pyramid. Now the vertices, one vertex, second vertex, third vertex, and fourth vertex. So this point is clear to us now that this diagram given to us is triangular pyramid. Now tell me the number of edges, please. Now as it is clear that it is an example of triangular pyramid, tell me the number of edges. Okay, Rishi is saying there are six. Fine. Others, please try. Yes, Tushita. Fine. Edges are six only as per you. Let us check. So we have like this figure. Am I having anything like that? No. Okay. Let's see. So like this is the base. Let me check. This is the base. This is the top. And like this, we will join. Let me count the edges. First edge, second edge, third edge, fourth edge, fifth edge, and sixth edge. So there are six edges only. So you are correct. Sir, there are four faces in triangular pyramid and five in square pyramid. Yes, beta, correct. Mokshita, correct, beta. Sir, there is a formula also. Yes, there is a formula also. But that is in class 8. Okay. Now tell me class, in this case, in this figure, how many faces are there? Please tell. Please tell how many faces are there in this given figure. Okay, it is there in the book also. Fine. Okay, some are saying 9, some are saying 8. Please confirm. Let's see the top one: 1, 2, 3, 4, 5, 6, 7, 8, and 9. If you see the outside, 4 faces are on that square pyramid, 4 faces on the outside, then 4 faces of the square, 8, and the bottom of the square, that is 9. So outside we have 9 faces of this combined figure. This is known as a combined figure. So this year only in class 8 we will learn the formula. Okay. Now edges. Tell me the number of edges in this case. Tell me the edges. There are 16 edges. Okay. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay. 16 edges are there. And how many vertices? Please tell me the vertices. 9. Fine. The formula before finding, if you see these three things, you can make a formula on your own. The formula is something like this. If I add F and V, if I add F plus V, can we say it is equal to E? Please tell. If I add F plus V, can I say right now it is equal to E? No. So what should I add in the E to make it balanced? What should I add in E to make this equation correct? That is very good. Plus 2. Now you can check on your own. This formula will work in all the cases. Now if I put F is equal to 6, if I put V equal to 8, the answer is 14. E, we are having 12 plus 2 is also 14. So the equation is correct. In this case also, let us check F plus V equal to E plus 2. If I put F equal to 4 and V equal to 4, we get the answer as 8. We get the answer as 8. E we have found as 6, and again 6 plus 2 is 8. That means we are correct. That means we have found the things correctly. Kritika, that's why I'm showing you this thing. Na? After finding all these things, you can verify by this formula. Okay, suppose you have two things with you and you want to find the third thing, that also you can find, which is the formula. Let's check this one. 9 plus 9 is 18 and 16 plus 2 is also 18. That means we have done it correctly. Sir, it is used to check our answer. Yes, you can say, you can check your answer, you can verify your answer with this thing. And in some cases, maybe I give you I'm not giving you any figure, I'm just giving you F equal to something, I'm giving you V equal to something, and I'm asking you E. That also will work. Okay. Sir, 6 plus 8 equal to 14 and 2 is already added to 12. Yes. Okay, now let's find the final one. Okay, you do it on your own today at your home. Try this one. Try to find the number of faces, try to find the number of vertices and the number of edges. You need a good level of imagination to do this question. Okay, try to utilize that imagination and find the answer and verify also. Now the next concept is nets for building 3D shapes. This also we have done as an activity. You can see the matchbox that we are having at our homes. This particular person has opened it, and when you fold it, you will get the same figure back. So nets are 2D figures. Nets are the 2D form of a 3D shape. So does the small triangle will also be counted? Does the small triangle will also be counted, Nana? Nana, in which case I am not getting? Please tell. Which small triangle you are saying? This one, na? Obviously, it will be counted. Actually, they have cut a slice. Suppose you are having butter with you. Suppose you are having a brick of butter with you and you cut the corner with a knife. It is like that. Now I hope it is clear to you, Nana. Okay, so just understand it like a brick of butter and you have cut the corner and you have got this shape. Now, okay, nets, as I'm discussing, nets are the 2D representation of a 3D figure. And these 2D, if you try to fold, you will get the 3D figure back. So we have done already the nets. You all have already explained it in that activity. You can use that concept. So you can see this is a net of cone. If you fold it, you get a cone. This is a net of cube. As we have seen, a cube has how many faces? 6 faces. 1, 2, 3, 4, 5, and 6. So as the cube has 6 faces, same is the thing with this one. The formula is F plus V equal to E minus 2. Lavya, you can always make the things like that. F plus minus V equal to E minus 2. Lavya, please check it one more time, okay? It is E plus 2 only. Please check again. Now see, the second one is cylinder. In cylinder case, you have a rectangle and 2 circles. So when you fold the rectangle and you paste the circles, what you get is a right circular cylinder. Sir, if we fold the nets correctly, then we will get the 3D figure back. Yes, Daksh, correct. So this way you can do. This is an example of cone. This you can try at home also, how to make a cone. Okay. This cone thing will also help you in many times in your life. Suppose you have some liquid with you which is dirty or some dust is there. What you can do is you can always have a piece of paper and you can form a cone of that, keep it on the bottle and pour the whole liquid. What will happen? The dust particles will be filtered out. Okay, fine. Okay, now this is the net of a pyramid, square pyramid it is. So nets are the 2D representation of a 3D figure, which if you fold, you will get the figure back. Okay. Animesh videos is on. Okay. Animesh, a net is a two-dimensional shape that can be folded to form a 3D shape or a solid. Yes, very good, Kritika. So if you want to write the definition, as I've told you already, you have done it, but still you can write like this. A net is a 2D shape that can be folded to form a 3D shape or a solid. Good, Kritika. Now, so these are the nets also. Now let's see 15.1, question number 1. They are saying identify the nets which can be used to make cubes. So to have a better idea, what you can do is you can cut these and then you can try by actually folding. A net is a 2D skeleton that makes a 3D shape when folded correctly. Yes, Vani, that is also correct. Okay, class, tell me, can we obtain a cube? Can we obtain a cube using this figure? Let's see. If I fold, it becomes this face. If I fold, this becomes this face. So these two are used now. Now what about this? Okay, this will come. I don't think it will work. Class, you have to do it practically. Now, as per me, I have used these two to make the two surfaces. Now, what will happen if I make it like this? Okay, what will happen? This one will come on this surface. This one will go on this surface. But what about this one? Will it go on the top? Class, I am able to see, I am able to visualize this thing, but you can do one thing. You can actually cut a paper and you can draw this thing. Okay, so if I assume, again, we see how I'm working on it. I am trying to see In my case, I am doing this thing. I am folding this like this. So this one I have used on this surface. This one I have used on this surface. Now it is up. Now when you fold like this one will come on this side, this one will come on this side, but the problem will be on the this one. It will overlap, I think. This one will overlap, the last one will overlap. It will not come on the top, as per me. You can try, you can try on your own. Okay, you can cut a sheet of paper and you can try different ways. If you are able to make it, it is possible. Okay, now the second one, same way you can try. Sir, it will come on top. Japlin is saying it will come on top. So class, you have to try by cutting it. Okay, because Japlin is saying that it will come on top, but I don't think it will come on top. I think it will come on the side only. Japlin, it is quite imaginative thing. You have to imagine it properly, then only you can understand this thing. If you're not able to imagine it in your mind, good way is to cut a sheet of paper, draw these squares and try to fold it. Yes, they can come, obviously they can come. Okay, now let's see second part. In this case, if I take this as base, if I take this as base, now what will happen? This will come on the side like this will come on the top. Class, am I correct? What do you say? If I fold these two, this will make the side face, this one will make the top face. Now this makes the side face, this one, and when you fold, this will come on this side and that will come on this side, and I think this will work. I think this will work. So this net is perfect. This will work, I think. Yes class, are you able to visualize this thing? Are you able to visualize like this way? Okay, so if any issue is coming in visualizing, you can actually do it practically and then you will have the habit of visualizing. Now let's see this one. Here also we have 6 faces. Now again, let me take the center one as base. If I take this one as base or the bottom face, what will happen? This becomes side face like this. This becomes this side face, because on the top it will turn like this. Like this we will have. Till now we have got these two surfaces, the side one. In this case, this also become a side face. This comes on this side, and I think that this will become the top. So this will also work, I think. Kritika is saying no, not work. Karthik is saying. Okay, let's see again. 1 second. Let me check again. Maybe I've done some mistake. So let me give some names, some numbers to this one to make it more clear to you. I'm giving these numbers 1, 2, 3, 4, 5, and 6. Let me make the third one as the base. Tell me what will happen to 2. 2 will come on which side? It will come on this side, the side face on this side. 1 will come on this side. If I'm not correct, if I'm not wrong, 1 will come like this. Again on the side. If I'm not wrong, 1 will come on this side because it is folded like this. Now 4 will be like this. So 4 will come on this side. This is your fourth face. Then fourth is on the top, fifth will come like this, fold, fifth will come on this side. After this, sixth is left flapping above. Sixth face is flapping above, and if you drop it like this, it will cover the top surface, as per me. So again, I'm telling you, if you are not able to understand it in your mind, you can try making it properly on a paper and then you will check it. Okay, Ekta is still saying it will not work, but Okay, okay, Ekta. Try to do it on a piece of paper, and if it is not working, we will see. One cannot come. Once again. Sir, one cannot come as it is on the side. Okay. One is on side only. Two is on the side only. Fourth is on the side only. Fifth is on the side only. The problem is with the sixth one. I think it will work. Six won't fit on the roof. Okay. Maybe sixth one is confusing. So do one thing. Try this. If sixth is not coming on the roof, it will not work. Because what will happen is four and five are top. Six is also on the top. When you rotate, I think it will come. Third is no, as per you. Okay. Then we can cut it properly and see. 1 second. Okay, tomorrow I will use a scissors also with you to check it again. Okay, this one is doubt one then. Please do this activity and let me know if it is working or not. Okay. Now, question number two is dice are cubes with dots on each face. Okay. Similar question it is. Try to use these two also. Okay. Tomorrow we'll check this one again. Okay. This third one, I will try to demonstrate with an activity. If it is working, then fine. But as per you all, it is wrong. Okay, then we will see. Okay. Okay, okay, Bani, I understood. You are saying that it is wrong, then I can understand. 15.1. One second. 15.1. Nets in. It is saying why you are saying, but it is saying nets in second, third, fourth, and sixth form cubes. Then why you are saying I'm going wrong? Yes, Bani. Okay, okay. Let me do one thing. Let me stop the recording.